So, yep, it's filming. We're back into another question, which is question 2. It tells you that sketch the sense and the sense inverse and say the domain and the range of each function. Okay, so since not only solving, let's go a look into the sense and the cosine. The sense of x, which is a sense hyperbolic sense, and we go into also this cosine of x. The sense of x is e to the x minus e to the negative x divided by 2. Its properties is 1, it's odd. You can see that f of x, all functions, if f of x is equal to negative f of negative x. And this is also applied, you can try it new on and you see that's actually true, it's not that hard. So the first thing that it's actually odd, the second thing about the sense of x, yeah, that's the most important thing. The sense is odd, and it looks like we're gonna see the graph of the sense of x, and the cosine of x is e to the x plus e to the negative x divided by 2. This is the second thing about the cosine of x. And it's even, which means that f of x is equal to f of negative x. That's in terms of cosine. Memorize this thing, understand it, and memorize it. And the last thing about the sine and the cosine is that about function. This is another thing about function and its inverse. First thing, only 1-to-1 function have inverses. So if the function is not 1-to-1, we have to constrain the domain to make the 1-to-1 function. This is not that much of the scope of the course. It's part of the scope of course, but it won't be, I don't think it's going to be examinable at all. So you have to understand that one is a function is 1-to-1. This means that if you draw any horizontal line, that will call the function only once. You can see it from the graph. And of course any function, all the vertical lines should if there's a graph of the function, the vertical lines should only cause the function once. And the second thing that if every function has a domain and its range or its image. As for f of x, let's say the domain would be some set A, and the image would be some set of B. So f inverse of x is domain will be the set B, and the domain for this function will be the constricted domain, the domain in which the function is 1-to-1 and have an inverse. So the domain will be B, and the range of the image, so we use the word image, and the image will be equal to A. So the domain will become, the set of the domain will become the set of the image, and the set of the image will become the set of the domain. And the function is inverse, we graph it as the inverse function is the mirror image around the mirror of y equal to x, the reflection of y over the function was reflected over y equal to x with the inverse. We can see what does that mean. So we want to graph the graph of sense of x. We say it looks like x cubed. So this is the sense of x, and if you want to take the image, will be equal to like will be equal to something like this. A sketch, and so the function there is this is the sense, and once you come and you do you reflect it about y to x, this means do it into two axes. So the graph of, okay, start of all of them. Fuck it, English. YouTube, don't delete the video, please. Sense of x This is the cosh of x, the cosh. And this is the sine inverse, that looks like the sinh inverse. It looks something like this. And this is the restricted. So once you have to cosh is even, and all even function is not 1 to 1. So you have to restrict the domain, and you put the line y equal to x. So this is the line. Take this one and you just reflect it about y to x. You get this one, and the cosh is an odd function. So you just you don't have to restrict the domain. You just reflect it along the line y equal to x. The domain and the range of the sinh will be equal to r, and the domain of the range of its inverse will be equal to again to r. Right now, this is the first question for marks. Very easy for marks. It's just the graph of. You have to know the graph of cosh and sinh and those famous functions. You have to know them. The second part of the second question, the second part of this question is to show you that I also forgot to mention this thing, is that about hyperbolic function, the cosine of ix will be equal to the cosh of x, and the sinh of and the sinh. This thing you have to memorize it before the exam. And sinh of x will be equal to negative I sine of x. Those two identities are important because you can convert any sine and cosine identity in terms of sinh and cosine of x. You have to know those identities and you have to understand them. You don't understand them, like say any trigonometric identity, it involves cosine, put it set the argument to a complex to ix, and you get cosh. Something involves sine of x, put it to negative I sine of x, or we can actually put, if we multiply both sides by I, we get I times I is negative. So this will be positive, and this will be this one. So as the end function, with sinh of x, we put it I cos of h. So for example, sine square of x plus cosine square of x is equal to 1. If you put the sine square, so put it at sine square of ix. This is just another angle. This is another argument. This is not angle because it's imaginary, but we actually expanded the definition of sinh and sine and cosine to the imaginary and to the complex plane. So we put this one as the argument, put it as ix. Sine, this is sine of ix all square, and sine of ix is I sinh of x, and once you square I, will become negative sinh square of x. So you have the sine of ix, put it as I sinh of x from this identity into this function, into the second identity, and the cosine of ix is just cos of x square will be equal to 1. And this is another identity. It's written in the last page. But you have to understand, because if this works for all the trigonometric identity. If you have one trigonometric identity and if you want to convert it into the hyperbolic identity, just use the converting factors. It's like this thing is like converting factor. You have something from the u, when x wanted to convert it to u, you just put x equal to u. Same thing here. Put cosine equal to the cosine of ix, put to the cosh, and cosine of I and sine of ix, you put it as I sinh of x, and you can convert it from one identity to another. The second part of this question is show that the sine inverse of the derivative is equal to this thing. You have to see something like, you have to understand about this question about two things. That the derivative of the sinh of x equal to the cosine of x, and you have to understand that dy by dy of cosh of x will be equal to the sinh of x. And you have an inverse function. How can we show that something is that thing? If you have inverse function, 1, 2, 3, 3 steps, you know them. But the inverse function, we have the sinh of x. Inverse of x. We'll put it as y. Put its limit as y, any variable. That's why that's math. You can do that. That's completely possible. And take the function. The function of the inverse function will give us back the argument, and this is the sinh of y. You can differentiate both sides with respect to the you want d divided by dx. You can differentiate it with respect to x, and you can differentiate it with respect to x. Derivative of d divided by dx of x is 1. Everyone knows it. I hope that everyone knows it. And the derivative of the sinh of, but that's sinh of y. That's not sinh of x. But y is a function of x. Y is a function of x. So you can use the chain rule. So it's d dy and dy dx. The change will be cosh of y times dy divided by dx. So dy divided by dx is equal to 1 divided by cosh of y. And what is y? We want to write everything in terms of the original function. So you have the cosh and you have the sinh, and they have the x. So you have to convert the cosh into sinh. What I was saying, if you have something, but that's in terms of y, you want to convert it into terms of x. The only thing that in terms of something that has to do, the only thing that's next to x is the cosh. So convert it into cosh. So you convert it into cosh. This thing I think will gonna be square root of 1 plus sinh the square of y. This is by the identity that I wrote in the beginning. Sinh n and h. That's the identity I wrote about the sinh square and the cosh square. This is from the identity of sinh square and the cosh square. And you know, and again, is sinh of y. Take sinh to both sides. Or from here, we say that x is equal to the sinh of y. So this thing will be equal to 1 over square root of 1 plus x squared. And notice that we don't actually have to put positive and negative. Why? Because we know the cosine function. I draw it, the graph of the cosine function, and we know that the cosine, I think I'd call it the cosine, I don't know why. But the cosh function is always positive, so you don't have to think about the positive and the negative thing. So you find the derivative dy divided by dx. What's y? Is this thing. So you find the derivative of the sinh inverse. This thing will always be for any inverse. Any inverse function, put it as y. So x, you take the function bx and that function of y, and make it implicit differentiation to get dy dx as this thing. It's a little bit hard in the beginning, but once you get used to it, it's so easy. Life is easy. Math is easy once you understand it. Because math is life. Life is math. Integrate by parts or otherwise. He told you to integrate by parts. First word you have, integrate by parts, so don't ever think about it. So you have change inverse of x dx. So you have something that you actually, why those two questions are related? I mean this and that. Because this question, you found that the derivative, that's defined the derivative. So actually there's, you can differentiate this thing. And what should I integrate if it's such change inverse? Like, what should I integrate? Of course you can't, you want to integrate x because it's an argument. Don't integrate x, please, please guys. You integrate 1 So you have something, so if you have something as u dv, which is u something that you can differentiate, and dv something you can integrate, you write the integral as uv minus integral of duv. In this case, what is something that you can u as the change of change inverse of x, and dv is equal to 1, and dv is equal to 1, dx, you put it as dx is equal to 1, so this is something that you can actually integrate with dx. V is just a function, so dv is equal to dx, which is equal to 1, so x, so this thing, so v is equal to 1, and du again, so you can, that's integration by parts. Integrate 1, you get, integrate 1, you get x, integrate 1, you get x, and you have that function, the change inverse. Differentiate this one, which is already differentiated, 1 plus x squared, and you multiply it by x, so the whole integral by part, integration by part becomes u is change inverse of x, v is x minus x, this is dx, because here dx, 1 plus x squared dx, and this is v is equal to x, so here v is equal to x, this is integration by parts, so I'm really messy in writing my stuff, so this is, and last thing is you just do a substitution. You can multiply here by 2 and multiply here by half, because the derivative of this thing will be equal to 2x, so this is 2, and multiply by half. So you can put u is 1 plus x squared, which you get an answer of a square root of, so after integration, normal integration, 1 plus x squared, time half plus c, don't forget the c, and x change inverse of x, this is minus there's no multiplication, it's minus, so x change inverse of x minus half square root of 1 plus x squared plus c, this is the integration of this function, and hence otherwise, so this one, which is easy, so right now you have the integral, you just substitute between -1 and 1, and it's like this is the function, this is the integral, and just evaluate it between -1 and 1, and you should get the answer 0. And the question after that is evaluate the first two non-trivial terms of the Taylor series of change inverse of x expanded around x equal to 0. So with Taylor series, have the function, take derivative, so have the function evaluated to 0. You will see if the function is 0 or not. So this change inverse from the graph, you can see it's actually 0, because change of 0 is 0. So change inverse of 0 is 0. You get the thing, it's like change of 0 is 0. Change inverse of 0 is 0. And take the first derivative, you already found the first derivative. No, we already found the first derivative, which is this thing. Sorry. We already found the first derivative. Evaluated at 0 should be 1. And so the Taylor series or any function, let's call this function the Taylor series of any function. Let's call this function f of x around x is equal to 0 will be equal to f of x naught plus f prime of x naught divide by 1 factorial x minus x naught plus f double naught x naught, second derivative, divide by 2 factorial x minus x naught all the square, and so in the terms goes so on to infinity. If you want to, not all the function to infinity, some of the function to infinity, other functions, some terms, but that's not a part of something that you should be worried the day before the exam. So there's this equation, and just substitute the first derivative, evaluate it as 0, and see if it's 0 or not. If it's 0, then you have to take the second derivative and the third derivative, then you get two non-zero terms, and that's the question. So it's all about finding this differentiation till you get two terms, till you get two terms, and you approximated the function correctly. So it's all about differentiation. Takes a little bit of time, maybe 3-4 minutes, but there's no idea, there's no big concept behind it. It's all about differentiation. Evaluate it at a value about the point that they want you to evaluate. It's not always 0. You evaluate it at x naught. In this case, it's 0, but it's not always 0. So yeah, this is the idea of Taylor series for single valued functions, and by this we finish the second question of the exam. So we have 2 more questions.